Hey there, in this video I'm going to try to go and see if there's an issue with the drilled holes activity for the CAD modeling feature. So I'm going to just kind of go through the process here, go back to engineering one. I'm going to be doing this in Fusion 360, which is opening up in the background. I'm going to download the file and go through it just to kind of reiterate this one, because this one is the hardest one on all of the CAD modeling features, that drilled hole one, because there's a lot of stuff to pay attention to. So let's go here. Topics. So we're going to bring up the instructions. First of all, because all of the stats, or I should say specifications for the holes, are all listed. Okay, so they're listed right here. A little bit hard to see, so I'm going to zoom in kind of extremely there. I'm going to go back into the topic, shared files. Rename these folders a little bit just to make sure you're getting the right one. So CAD modeling features for Fusion 360. Let me sort these by name. All right, drilled holes. I'm going to right click on that one, download it. Okay, I'm going to go back to Fusion 360. I'm going to file, open. I'm going to open from computer, which is a nice option. If you're in 360 on a Mac or PC. So drilled holes, there it is, open. All right, so there's 5 points here. So you go ahead and you hit hole, and it's probably going to, then you select your point. Okay, it doesn't automatically select them. And then all the stats for the hole are over here. Now, admittedly, this looks different than what the instructions look like. All right, so let me get back over to the instructions. So the first one's a through hole. It's not really a through hole. Through hole is supposed to be, literally goes all through the material. I don't know why they call that a through hole, but anyhow, 0.75 inches. It's a tapered drill point, and it's 0.25 inches wide. And the drill point angle is 118. All right, so if we go back to Fusion 360, this is going to be a 1/4 inch wide, 5 inches wide. Oh, 118 degrees, that's the same, and it's 0.75 inches deep. All right, and the hole type is simple tap type, and that's it. Okay. All right, I'll do another hole now. Oh, you know what the thing is? It's hard to see, actually. Oh, I wish I should have changed the material. So you could actually see what the heck's going on in there. How do I do that in this? Oh yeah, physical material. All right. They were smart in the one thing to make it a plastic and clear acrylic. I'll select clear acrylic. So you have to drag it, hit it, then you can see what's going on inside of it. Clear is almost too much. Let's see if I do epoxy resin, if it makes it a little tinted. Let's delete that. No, I want something that's, clear, but maybe like a little bit peak plastic. I don't know. Let's see what that one looks like. No, I want something that's maybe smoked. Phenolic resin. There you go. There you go. Phenolic resin. Look at that. So you can change the material type. I right clicked on it, and I went to physical material, and that got it done. I like that. So now you can see inside of it. All right. So when you move around, you can see the drill tip. Everything looks good. All right. So now I got to make sure this sketch is visible again with the holes. All right. So I went over here, turned the sketch on. Let's do another hole on this point, and it's just going to use the same stats as the last hole was. So I got to go back over to my things. This is the counter bore now. All right. 0.75, 0.25, 0.375 through all termination. All right, so counter bore is the whole type, counter bore. All right, the extent, it's gonna go through all, so you're gonna hit all here, and that'll make it go through the whole material. Hole tap type is still just simple. Drill point doesn't matter because we're going all the way through everything. Then we have to change the stats. So this one's 0.75. The depth is 0.25. And the hole width is 375. And then, okay, there's that one. All right, so another hole. I'll click this. I'll tell you what I'll do is when I'm done with this video, I'll go back and change the material and put this drilled hole file back into that folder. So if you want to re-download it as the clear plastic, that would probably be good. Now this one is going to be a countersink. I'll go back to the instructions and show you that. Countersink, 0.75 wide, 83-degree angle, 0.375 distance, and it's still through all. So I'll go back to Fusion 360. It's going to be a countersink this time. Oh, that's weird. It doesn't save that. That's unfortunate. So this is 0.75. Width is 0.375. Did I type that wrong in the last one? I might have. 118 degree there, 83 degrees at once for the angle, which is negligibly different, and that's it. So it's countersink, still a simple hole, and the drill point doesn't matter because we're going through everything. All right, the next hole, this one here is going to be a tapped hole. So we're gonna still go through everything. We're gonna make it a simple hole, so no seat. Those are called seats. And the hole tap type, it's going to be threaded or tapped. All right, and the size of it, now I have to go down here and select the size. Let me move myself over here. Size of the hole is going to be 0.25. So you got to select that first, and then it'll automatically select 1/4 by 20 UNC. 1/4 by 20 UNC standard thread. Everything is there. Oh, you can model it? Oh my gosh, that's awesome. You can't model it in Inventor unless I've never noticed that option. So when I hit OK, does it actually cut it? It does. Look at that. That's awesome. That's new. It used to be when you thread stuff, it wouldn't actually cut it, model it. It would just make it look like it was threaded. Oh boy, that's a game changer right there. That's an overused phrase, but that really is. Now I want to see if I can actually do that in Inventor. It's not. Maybe I've been missing this whole time. Anyway, the last one, this point, it's actually going to be a clearance hole tap type, simple clearance. All right. And what's cool about the clearance hole is you just select the size screw you're using. So if you go and look at the stats, it says it's a hex head bolt. Oh, I forgot to talk about this one. 1/4 by 20 UNC. You got to make the size for clearance hole. It says hex head bolt 1/2 inch. So you go back to Fusion 360. Hex head bolt size of metric. We don't want metric. We want unified screw threads, and it's a 1/2 inch hex head bolt. And what it does is it makes the hole just a little bit bigger than a 1/2 inch to allow enough space on either side of the bolt, so it's a nice smooth fit. You're not going to have to thread it in there. Very cool. Hit OK. And that's it for CAD, the drilled holes. Thanks to the person who asked a question about this. That was worthwhile going through. I guess I hadn't done a good job in the video of this one because I don't remember. I don't remember actually doing this. So hopefully that helps. I will upload this with the clear plastic without the holes in it as soon as I'm done with this video. Okay, just gonna hit undo a bunch of times and get rid of that hole. Okay, and then right click again. What I did, if you don't want to go through this, so let's say you open up the file and you want to do this from scratch, you right click, escape, right click on this, and now where'd it go? This is crazy. Oh, come on, what's going on here? Escape, you select it like this. right click, physical material. So I had to select it all first, and that one was phenolic resin. That was nice and clear. Then you just drag it, throw it on it, close, and done. And again, if you want to export something, you have to export it. Drilled holes, downloads, okay. Let me put it somewhere else. Again, this is, this is nothing to do with what you're doing right now, but do I have a folder going? There we go. I'll download this folder, overwrite it, and I'll put it again on student share. All right. Hopefully that helps you out. Talk to you later.